This video corresponds to looking for Pythagoras, problem 3.3. To be ready, you will need your book open to problem 3.3, this lab sheet, and a pencil. Have those things ready and then continue the video. In this problem, you will investigate finding the distance between 2 points. Let's look at point K and point L, for example, on this lab sheet. Because this distance is at a slant or diagonal, it is harder to calculate the actual distance. It would be much easier if it was on a horizontal or vertical line. You may remember the town of Euclid in the earlier problems in our book, and we learned that the diagonal distance, or the helicopter distance, is often shorter than the driving or vertical and horizontal distance. For example, if I was going to drive from point K to point L, I would have to go in straight lines, and it would take me 5 plus 2 or 7 units of distance to get from point K to point L. However, in the geometric plane, or by way of helicopter, we can go in a straight line, so we could go straight from K to L. Now we know that that distance from K to L is going to be longer than either of the short legs of the triangle that we drew, but it's going to be shorter than the combined distance. For example, this distance here would be 5 units, and this distance here would be 2 units, for a total of 7 units. We know that K to L has to be shorter than 7 units, but the trick is to find out exactly how long it is. The good news is that we learned previously that there's a relationship between the square of the leg of a right triangle and the square of the other leg of a right triangle, and the square, and this one won't be drawn to scale exactly, but the square of the hypotenuse of a triangle. And we learned that if you add the square of the legs, and this small triangle would have an area of 4 square units, this bigger leg squared would have an area of 25 square units, and we found that consistently if you add those two areas, you get the area of the hypotenuse squared. So this hypotenuse would have the area of 29 if we made a square out of that hypotenuse. That means the side length is the square root of 29 units exactly, because the side length of a square is exactly the square root of the area of that square. This relationship between the square of the legs and the area of the hypotenuse of a right triangle is called the Pythagorean theorem. And if we call the short sides of the triangle the legs A and B, and the long side C, the hypotenuse, then we've discovered that A squared plus B squared equals C squared. So let's go back to our original lab sheet. What the Pythagorean theorem means for us is that we're trying to find the distance from K to L in a straight line. Then if we make a right triangle out of that straight line, and that diagonal distance is the hypotenuse, we have a leg and a leg. Then if we call one of these A and one of these B and the hypotenuse C, and we know that A squared plus B squared equals C squared, then we can use these numbers to find out the length from K to L. For example, in our case, A has a distance of 2. That leg is 2 units high. B has units of 5. The length of B is 5 units long. And so if I put 2 in for A and 5 in for B into the Pythagorean theorem, I end up with 2 times 2 is 4, and 5 times 5 is 25, and I know the area of C squared, as we discussed before, is going to be 29. And if I know C squared is 29, if I do the inverse operation of that and I take the square root of both sides, then C, the distance of the hypotenuse, the length from K to L, is the square root of 29 exactly. Now your job, using your Looking for Pythagoras book in problem 3.3, is to find the distances on this lab sheet. For example, from point L to point M, and point M to N, etc. You'll need to read the questions on page 35 and answer them thoughtfully. And you can use this lab sheet as a tool to get that done, as well as the ideas discussed in this video.